let's talk a little bit about the quadratic formula. Someone had asked to kind of show how we simplify the quadratic formula results. So if I'm trying to solve, so this is my function x squared plus 8x plus 3. If I'm trying to solve x squared plus 8x plus 3 equal to 0, you can try to factor, but this one doesn't factor because there's nothing that multiplies to 3 and adds up to 8. At least no nice integer numbers. We can use the quadratic formula. So when you use the quadratic formula, it's really important to remember, you're not just getting two numbers, you're getting the x values that solve this equation. So you're actually getting x equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Where in this case, right, a is the first coefficient, b is the second, c is the third. So a equals 1, b equals 8, c equals 3. Here they're all positive, but it is important to make sure you pay attention to the sign of each of the coefficients. So here we get x equal to negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 3 all over 2 times 1. And we should simplify this as much as possible. This is negative 8 plus or minus the square root of 8 squared is 64. 4 times 1 times 3 is 12. So 64 minus 12 is 52 divided by 2. Now be careful. I've definitely seen people make the mistake of saying, oh, negative 8 divided by 2 is negative 4. This is not equal to negative 4 plus or minus the square root of 52. Each of these pieces get divided by 2. So what you could do if you really wanted to is you could break it up right now and say it's negative 4, now it is going to be equal, divided by 8 plus or minus the square root of, sorry, divided by 2, apologies, whoa, let's back that up. Negative 8 divided by 2 plus or minus the square root of 52 divided by 2. Now, this is going to simplify the negative 4 plus or minus. When you're simplifying what's inside the square root, you should try to factor out any square factors. So 52 has a factor of 4. Right? 52 divided by 2 is 26, divided by another 2 is 13. The way I actually remember this is 52 is the number of cards in a deck, and there are 4 suits: aces, diamonds, hearts, and clubs, and there are 13 cards in each suit: ace, 2, 3, 4, 5, 6, 7, 9, 10, jack, queen, king. So 52 is always 4 times 13. And then when you take the square root of a product, you can break that up as the square root of 4 times the square root of 13. Or as I like to think of it, the 4 comes out by taking its square root, and you get negative 4 plus or minus square root of 4 is 2 times the square root of 13 all over 2. And then 2 divided by 2, those can cancel, and your final answer in this particular problem is negative 4 plus or minus the square root of 13. That's how you would simplify that as much as possible. I think this came up because there was a question on the first homework asking about finding the inverse function of something like this. F of x equals x squared minus 4x plus 3, where x is greater than or equal to 2. And then wants to find the inverse. I drew the graph here so you can see this function is 1-to-1. Right? Usually a parabola, a quadratic, would have the other side of this here, right? Like that. And it would no longer be 1-to-1, which means it wouldn't be invertible. But since we're starting here and just going that way, it is a 1-to-1 invertible function with a limited domain. So the way you have to find the inverse here is the same as what we did before. And this should look more parabolic. Sorry, it looks kind of wrong the way I've drawn it there. Fix that. Okay. So the way you find the inverse is we switch x and y. So instead of writing y equal x minus 4x plus 3, I'm going to write x equals y squared minus 4y plus 3. And then we're supposed to solve for y. And there's a couple ways you can do this. I'm personally a fan of completing the square, which I'll show you second, but it's probably more natural to use the quadratic formula. Here's the thing though, when you're using the quadratic formula, just like on the other side, you can only use the quadratic formula if you're solving a quadratic equation equal to 0. So this one is actually, I think, tricky. Because you have to bring this x over here and treat it as part of the c term. So here I'm going to have, subtracting x from both sides, 0 equal to y squared minus 4y plus 3 minus x. So what I've really got here is my a value is 1, my b value is -4, and my c value is 3 minus x, which is strange, but it is what it is. So then, using the quadratic formula, my solution, so again, here, it was a quadratic formula in x, so I got x equal to some stuff. Here it's a quadratic formula in y, so we need y equal to some stuff. Y equal to -b, so -4 is 4, plus or minus the square root of -b squared, minus 4 times 1 times 3 minus x, all divided by 2 times 1. Right, simplifying, I get y equal to 4 plus or minus the square root of 16 minus 4 times 3 is minus 12, minus 4 times minus x is plus 4x, all over 2. I can simplify a little bit further and get 4 plus or minus the square root of 16 minus 12 is 4 plus 4x all over 2. This actually simplifies really nicely. I'm going to kind of write it down further here. So if I break that up, I can factor out a 4 from inside here. So I've actually got 4 plus or minus the square root of 4 times 1 plus x all over 2. And again, this is what y is equal to. And finally, bring out the 4. The square root of 4 is 2. So this is equal to 4 plus or minus 2 times the square root of 1 plus x all over 2. And finally, divide each thing by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So you get 2 plus or minus the square root of 1 plus x. And we're almost done. So if y is equal to 2 plus or minus the square root of x, well, that's the thing, that's not a function, right? If I've got 2 plus the square root of 1 plus x, well, let's see. That's going to shift it 1 left and 2 up. So 1 left and 2 up, so I'm starting here. And if y is equal to, I'm going to actually erase this here. So if y is equal to 2 plus the square root of 1 plus x, well, that's going to get bigger and bigger y values, right? So like if x is 0, I get 2 plus 1, which is 3. If x is, I don't know, 3, 1 plus 3 is 4, square root of 4 is 2, I get 2 plus 2, which is 4. So when x is 1, 2, 3, I get 4. And so this is y equal to 2 plus the square root of 1 minus x. On the other hand, if I did the minus would be this other half of the sideways opening parabola like that. Now here's the thing. We know we want this to be our inverse function because this inverse function has the same range as the domain of the original function. So that's how we're able to tell that for this problem, f inverse of x is 2 plus the square root of 1 minus x, not 2 minus the square root of 1 minus x. All right.